This is lesson 4, more examples of functions. In the last couple of lessons, we looked at several linear functions and the numbers that are assigned by the function in the form of a table. In table A, the context was purchasing bags of candy. For the function in table A, the rule that described the function was y equals 1.25x. Should we restrict the values we can use for x? Yes. X should be greater than or equal to 0. In other words, it should be positive. And it should be a whole number. No fractions. Or decimals. Okay. Next, in table B, it was the distance traveled by a moving object. Get this out of my way. With respect to table B, the rule that describes this function was y equals 16x squared. Does this problem require the same restrictions on x as the previous problem? And explain. Since x is time, it should be greater than or equal to 0, and therefore positive. But this time, we can use fractions and decimals. Okay? So next, we describe these different rates as discrete and continuous. When only positive integers make sense for the input of a function, like the bags of candy example, we say that it is discrete rate problem. In other words, do not connect the points. When there are no gaps in the values of the input, for example, fractional values of the time, we say that it is a continuous rate problem. And we do connect the dots. Or sorry, the points. I feel like I'm in a game. Oh, connect the dots. Okay. So example 1 says, water flows from a faucet at a constant rate. That is, the volume of water that flows out of the faucet is the same over any given time interval. If 7 gallons of water flow from the faucet every 2 minutes, determine the rule that describes the volume function of the faucet. Y is the volume of water in gallons that flows from the faucet, and X is the number of minutes the faucet is on. So if you remember from our previous lessons, we have to write this as 7 over 2 equals Y over X and we cross multiply, and we solve for y. So we have 2y equals 7x, and divide both sides by 2. And we have y equals 7 over 2x. So therefore, next it says, what limitations are there on x and y? So both x and y should be positive, because they represent time and volume. Next, it says, would this rate be considered discrete or continuous? And explain. It would be continuous oh, and I spelled that wrong. We can use decimals and fractions. So next, consider the following function. There is the function g, so that the function assigns to each input the number of a particular player and output their height. For example, the function g assigns to the input 1 an output of 511. The function g assigns to the input 2 what output? 5 feet 4 inches. Could function g also assign to player 2 the second output of value 5, 6? For example, the answer is no. Function g assigns height to a particular player. A player can't have two different heights. So C says, can you think of a way to describe this function using a rule? Well, of course not. There's no formula for such a function. The only way to describe the function would be to list the assignments shown in part in the table. D, can we classify the function as discrete or continuous? Discrete. A person is one height. Or another. Not two heights at the same time. This function is an example of a function that cannot be described by numbers or symbols, but it is still a function. So for practice, a linear function has a table of values below related to the number of buses needed for a field trip. Write a linear function that represents the number of buses needed, y, for x number of students. Well, as always, we have 1 over 35 equals y over x. They have to match, y to y, x to x. So cross multiplying, we have 35, y equaling 1x, dividing both sides by 35. We have y equals 1 over 35x. So describe the limitations of x and y. X and y must be positive. No fractions or decimals. Is the rate discrete or continuous? It is discrete. Does the entire 8th grade student body of 321 students is going on a field trip? What number of buses does our function assign to 321 students? Well, using our function, we get an answer of 9.1714. Let me get the rest of that answer there. When we turn on our calculator here, we get our answer of 285. And because it is part of a person, we have to round that to 10, or part of a bus. So we must round up. Ten buses. So next, we have a function produces the following table of values. Can this function be described by a rule using numbers? The answer is no. Can't be described. Or a rule, because they are objects. It says describe the assignment of the function. The function assigns to each fruit the color of its skin. Then it says state an input and the assignment the function would give to its output. Input of orange as an output of orange. And that ends our lesson.